5 predicted calculation questions with answers for paper 1 AQA GCSE Chemistry Exam 2024. First question, calculate how many particles or how many molecules of X are in 100 gram. This X could be anything like water, for example. To do this calculation, you need first to find the relative formula mass of water, which is 18. And then you need to find the number of moles in 100 gram. So moles, number of moles equals mass over mR. So 100 divided by 18, this is 5.56 moles. So this is the total number of water molecules. And then to find the number of particles, you can multiply the number of moles by the Avogadro constant. In your exam, the Avogadro constant will be provided, and the Avogadro constant is 6.02 times 10 to the power of 23. Avogadro constant is the number of particles in 1 mole of any substance. So when you multiply the number of mole by Avogadro constant, that will give you the total number of particles in that particular number of mole or in that mass. Question 2. 1,800 kilogram of aluminum oxide is electrolyzed. Work out the expected mass of aluminum produced and give your answer in kilogram. So normally they will provide you with the balanced equation for the electrolysis, where 2 moles of aluminum oxide will be electrolyzed to give you 4 moles of aluminum and 3 moles of oxygen. First of all, you need to work out how many moles are there in the 1,800 kilogram of aluminum oxide. To do this, you need to calculate the relative formula mass of aluminum oxide, which is 102. And then find the number of moles of aluminum oxide that will equal the mass of aluminum oxide in gram divided by the mR. The mass provided here is in kilograms, so we have to change this into gram, and to do so we need to multiply this by 1000 and divide this by 102, which is the mR of aluminum oxide. So the total number of moles of aluminum oxide is 17,647 moles. Looking at the balanced equation, you can find that 2 moles of aluminum oxide will give you 4 moles of aluminum, which means that the number of moles of aluminum will equal double the moles of aluminum oxide. So you need to multiply this number of moles by 2, and then the number of moles of aluminum is 35,294 moles. Finally, you need to find the mass of aluminum that is produced. The mass will equal moles times the relative atomic mass of aluminum. So the moles that we found, 35,294 times 27, which is the relative atomic mass of aluminium. That will give us the total number of the mass of aluminium produced in gram, which is 925,938. And they wanted the answer in kilograms, so you need to divide this by 1000. So you will end up with your mass as 952.94 kilogram of aluminium. Question 3. Calculate the relative atomic mass of element X, and the element X could be anything like argon. They will give you the different isotopes and their relative abundance. So there are 3 isotopes of argon. 40 with a relative abundance 95%, 39 with a relative abundance 3%, and 38 with a relative abundance 2%. So to calculate the relative atomic mass, it will equal the relative abundance of isotope A times the mass of isotope A plus the relative abundance of isotope B, mass of isotope B, plus the same for isotope C. All of that divided by 100. So when you do this, it's 40 times 95 plus 39 times 3 plus 38 times 2 divided by 100, and you end up with 39.57, which is the relative atomic mass for argon. Question 4. Calculate the percentage of element X in compound Y. For example, they can ask you to calculate the percentage of hydrogen in sulfuric acid. The relative atomic mass of all of the different elements will be provided in the exam. So the equation is that the percentage mass of an element in a compound equals the relative atomic mass for that element times the number of atoms of that element in the compound divided by the relative formula mass for the compound times 100. So for sulfuric acid, the relative formula mass equals 98 after we do the calculation. And then the percentage mass of hydrogen and sulfuric acid will equal 1, which is the AR of the hydrogen, times 2, because there are only 2 molecules of hydrogen and sulfuric acid, divided by the 98, which is the MR of sulfuric acid, times 100, and the answer is 0.04%. Question 5, which is almost a guaranteed question in your exam, where they ask you to calculate the concentration of an acid or a base after a titration. So calculate the concentration of sulfuric acid in mole in decimeter cubed and gram per decimeter cubed when 25 centimeter cubed of sulfuric acid is titrated with zero point 0.1 mole per decimeter cubed sodium hydroxide. The mean volume of sodium hydroxide added is 32.6 centimeter cube. Normally in your exam, they will give you the different values from the titration and ask you to calculate the mean value for the volume of sodium hydroxide that was added during the titration. Remember when you do that, that you exclude any anomalies. So to answer this question, first you will need your balanced equation for the neutralization reaction. So the balanced equation, 1 mole of sulfuric acid react with 2 moles of sodium hydroxide to give sodium sulfate and 2 moles of water. So first of all, we need to calculate how many moles of sodium hydroxide reacted when we reach the end point and when we reach the neutralization point. So moles of sodium hydroxide will equal the concentration times the volume of sodium hydroxide in decimeter cube. Remember that they provided you with the volume in centimeter cube. So we need to change this into decimeter cube. So concentration is 0.1, and then the volume, when we divided this value by 1,000, is 0.0326, and then the number of moles of sodium hydroxide is 0.00326 moles. Now looking at the balanced equation, you can see that 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. So the number of moles of sulfuric acid will equal half the moles of sodium hydroxide. So you have to divide this value by 2, and that will give you the moles of sulfuric acid. So it's 0.00163 moles. Now we need to change this moles into concentration. So concentration of sulfuric acid in mole per decimeter cube will equal the number of moles divided by the volume of sulfuric acid in decimeter cube. Again, they provided you the volume of sulfuric acid in centimeter cube. So we have to change this into decimeter cube. So we divide the moles divided by the volume in decimeter cube, which is 0.025. That will give us the concentration in mole per decimeter cube, which is 0.0652 moles per decimeter cube. Now they also ask you to provide the concentration in gram per decimeter cube. So to change from mole per decimeter cube and to gram per decimeter cube, you need to multiply by the relative formula mass of sulfuric acid. So calculate the relative formula mass of sulfuric acid, that will give us 98, and then the concentration in gram per decimeter cube equal the concentration in mole per decimeter cube times the relative formula mass of sulfuric acid. So the value we obtained here times 98 will give us 6.39 gram per decimeter cubed. Now you found the concentration of sulfuric acid with the two terms.